Our first lesson, our first example is by your choice on page, what page is the beginning of 5-2? What? 370 or 380, 387. On page 387, you guys get to choose the dictation of the assignment. Not the assignment. Choose evens. Pick any evens on that page or on the other page. Can I actually keep that one second because number 24 is actually one of the harder ones. That is not odd. You're done talking. 38. Let's see what the old 38 is. Not that this one will be on your quiz, but we can do it. Maybe? I wonder where that scratch paper is. That's scratch paper, isn't it? Oh, Bradshaw. Is anybody, if you'd like to tear into page 374 and tell me what the secant of pi halves minus x is? I kind of know it, but cosecant, I believe. Anybody want to look that up for me on page 374? What? Was that a lesson plan? Order? It's because we're not using that book, so some of the items we've already used. Therefore, I knew that we should throw some triangles like law of sines and law of cosines because we don't use any of that other chapter the rest of the time with some of the stuff that we just learned about right triangle trig. Hence why we did that. You're probably, now we're back in 5 because we did 6 and you're wondering why we went from 5 to 6 or 6 to 5. Yes. Did I answer your question? Thank you. It's part of life. Okay, this I do believe is cosecant. Rafe, agreed? Secant of pi halves minus x is cosecant. Thank you, Rafe. Because it's on page 374. Yes. If you would like to learn, I can show you the reasoning right now. Ready? Boom, boom. Here is x. This is pi halves. Did I not? I think, I can't remember. I shared it with you just barely. Okay, if I stand here and do the secant of pi halves minus x, the secant of that would be c over a. Well, if I stand down here, who is c over a? Cosecant is. Does that answer your question? Kind of the same way. I just had to draw a triangle. Hi, Mr. Rude. You are more than welcome, Mr. Rude. So therefore, I'm at cosecant squared minus 1. And what is cosecant squared? Minus 1. Cotangent squared. Notice the nice thing today is we know where to stop. It tells us where to stop. There is an equal sign. Now, when I do this, I get to 2 options. Here's my equal sign, is this line. I can work on side A, blah, 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 and then get it to side B. Does that make sense? I can work on side B and get it to look like side A. Or I can work on side A and work on side B and get them to be the same idea. So like say if they equal both cosecant, don't they prove each other? Because you got this side to equal this side. Now, you are never, ever, 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 ever going to work on both sides. What do I mean by that? You cannot add one to the other side. You cannot square both sides. You cannot times by sign to both sides. You only can work at one side at a time. It is verifying. It is not solving. There is a difference between those two. Anybody want to do some other than number 38? We'll do 24 on the fourth one. Huh? I don't know. It's on the quiz. 28. What does it say? 1 plus sine y. Yes, it is. One plus, hold on. Sine negative y. This is once again one of those identities I don't expect you to memorize, so if you go check it out, you can. I believe, if that's a bad writing, I can rewrite it. Yes. I did tell you guys in your notes that you could look back there. Yes. Nope. Now, what if this was X and this was Y? Would that matter? That matters. Okay, so really quick, guys, the identity here is it says that sine of negative Y is negative sine Y. It is the even odd rule. Because that's an identity. Okay, so now I just use good old Pythagorean, not Pythagorean, but I distribute, right? Because this is a difference of squares. I mean, conjugate pairs and conjugate pairs go to difference of squares, right? So that's 1 minus sine squared. And what is 1 minus sine squared equal? Cosine squared. Is that where I was supposed to go? Is that what the equal sign said? I have the y. That's a y. That's a y. Oh, on the bottom. Thank you. You guys should date each other. You guys flirt every day. It's okay. Doesn't mean you can't steal it from her, from him. Not it. You're not an it. Still her from him. Just saying, it's possible. I've seen it happen. Hey, pick another one, Miss Kelsey. $34. I knew that one was coming up sooner or later. 1 minus cosine? What? Over? And I know what it equals. This equals no square root. Is that it? Okay. Anybody have an idea? Multiply what? Go with it. On the left side. The conjugate is what we call it. We times the conjugate top and bottom. Everybody agree with that? Then we have a big old square root again. And I have 1 minus cosine times 1 minus cosine. I don't know about you guys, but that's 1 minus cosine quantity squared. That looks like a 3, but it's a squared. And then the bottom, they are conjugate pairs that time to be difference of squares. Anybody give me a different name of 1 minus cosine squared? Sine squared. Oops. It was a squared, it just didn't go there. What's the square root of something squared? Just itself, right? Now, why does the top one have an absolute value? Anybody remember one of my cult sayings? You're part of my cult, damn it. Did you guys leave it already? No, you guys are ruined. You are truly a cult member. Even root, odd power, even root, odd power. Did it come from an even root? Did it come out odd power? So therefore absolute value. Because of that minus sign, it does make a difference. It should be fine. By the way, I do follow. This is the longest test for me to grade. Because I got to look at every individual step. Because you could, like I said, just because I do it one way, does that mean it's the only way to do it? There's plenty of different ways to do it. And so your way might be different than what I thought, right? So that's why I have to check. I'm like, okay, that's realistic. That makes sense. Oh, that makes sense. That makes sense. And I have to follow it. You do, but it doesn't mean that it's not, that doesn't mean there's not multiple ways to do it. It'll say verify this. That's what your homework is today. Verify that these two identities are equal, or that these are two equal equations. Sir. No. If you got there, why would I mark you down? Well, that should, you guys would all have F's every day. Especially Paige. I didn't say you. I didn't say you. We all understand Paige is a little hemorrhoid. Pain in my butt. I'm like on a ride. All right, let's go to the good 24. 24, read it to me, someone. I think it's cosine of x. Let me see if I got it. I think I got it. Minus cosine of x over tangent. Oh, I was wrong. Hold on, brother. This I know. This is sine x, cosine x over sine x minus cosine x. What side would you work on, Riley? Riley, I didn't hear what you said. Me neither. Which side do you think you should work on? I would work on the left side because it's uglier. We all know it's easier to fix something ugly. Look at Moana. She was an 8-cow wife after that. She just all of a sudden turned pretty. Wrong thing. What? Yeah, what was the woman? Not Moana. What was the girl's name in that though? Mohana, you ugly. That's what it is. Yeah. See, we all know we turned her pretty after she got 8 cows given about her. You know, she was an 8-cow wife. And all of a sudden she was like blushing with goodness. Yes. Johnny Lingo is a smart man. Okay. Anybody have an idea? How about you, Janice? Just an idea. Might be wrong, might be wrong, might be right. We don't know. Guys, shut up. This is 4th period. I've had like 7,000 calories of sugar. And it's not even the end of the day yet. Huh? Have you ever looked at the Samoas? Don't ever look at the nutritional facts of Samoas. You can only have 2 in a serving, and they're almost 200 calories. Each cookie is roughly 100 calories. Only 1,000? I'm just waiting, guys. This is your guys. Help me out, help me out, help me out. Denise, anything? All right, 5, 4, 3, 2, 1. Yes. Can you give me a better, tell me what that means, because that's kind of like vague. What do you mean by everything? Okay, I like your idea. If we were solving, I like that a lot. But we're not solving, we're verifying. So as I said earlier, we can only work on one side. So I can't from this side and put it on the left side. But I like the idea. Like I said, you might be wrong, you might be right, and that's a good chance. But we're not solving, we're verifying. So we only want that stuff to stay on one side. Page. Oh, nuts. I don't know what tan means. Thank you. That is correct. Tangent squared plus 1 does equal secant squared. They do not work. No, ma'am. No, ma'am. Good, good. I like that because a lot of people try to do that. So that's a very good question. Her question was, is 1 plus tangent squared, or tangent squared plus 1, same thing, equals secant squared, right? That's an identity. I bet this is what I'm assuming you're saying. Does 1 plus tangent equal secant? That's your question, right? That is not true. That is not a true statement. Okay? That is fake news. Yes, ma'am. No, ma'am. Still the same thing. Can't do it. You would have to factor them. Yes, sir. So you want to get common denominator because you see a number minus a fraction, right? I like that. Let's go there. No, it's what I would do. Nope, so all I gotta do is just go 1 minus tangent. And I gotta do it to the top as well, right? Let's do yellow right there really quick. Not in the white, it doesn't. Okay, I got a common denominator. Now, once again, this is the side I want to work on. Can I work on both sides? Sure I can, right? But right now, I'm just working on the left. Let's just play around with the left. I'm going to distribute that through. Okay, so I get cosine x minus tangent x cosine x minus cosine x. Anybody have a question on how I got that? Give me one moment with that. Okay, your question was what again? I'm sorry? Or your statement? The cosine square, the cosines would, because I have a positive and a negative, and they're all in the same denominator, aren't they? So yes, that is a true statement. So now we're here. No, sir, they don't. Once again, why? Why do the tangents not cancel out? One is multiplying and one is addition. So really, if I put a number in for x, wouldn't I find the tangent and then go 1 minus and then divide it? Only time I can do that is if this was 1 times tangent, yes, I could. But because that minus sign's there, I cannot. How about this? What is tangent cosine? Anybody know? I'll just do it over here really quick. Who said it? Somebody said it. It is Teresa sine. Yep, because that's what it is, right? Everybody see that? Because tangent sine over cosine. Is everybody there? Okay, this is where I went wrong. Now, my way works that I tried, I just didn't persevere. And I kind of looked around, I'm like, oh, nuts, this is getting ugly. I should stop. And I was like 4 steps away. Okay. But there's many different ways, and that's the thing I am encouraging. But the dude on the other class, he decided to do something a little different. Anybody know what he did? He multiplied what? I cannot, once again, multiply it to the other side. I can only work on one side. So if you want to start with the other side, I can work on the other side. Would you like me to work on the right side? You can't multiply by both sides. Once again, you're working on one side or the other, not both sides. Does that make sense? If I work, so I could stop on working on the left side, which I'm here on the left side, correct? Is everybody there with me? Then I could work on the right side to get him to look like that, but I'm not there. That's not what we decide. Yes. What again? Thank you. Good job. That's what I would do. Can't flip it yet, though. But you do have an idea. This is the easy way. It is not what I did. Did anybody know the other way that I did? As a jailbird, drinking out of an item, just got done eating. I times by the conjugate. And I'll show you. I'm actually going to show you because I want to show you that it can be done in multiple ways. Okay, so kind of close what you have there, Isabel. So we did this, and this is good. Guess what I am going to do, though? Me, Mr. Vijay Roberts, says I'm going to times by cosine x top and bottom. Can I do that? Because that's working on one side, right? I didn't work with the other side. I'm like, hey, wait. Did you go? Yeah. And? Was it delish? You switched cookies? No, I ordered a pretzel. You know yourself. You should have stuck with a cookie. What's a real nacho cheese, by the way? Because the stuff that usually comes out of gas stations, I would not consider that real. But I like it. I think Nicaragua, but whatever. Okay. Yes. Nice. A big fella could pound some stuff. Yeah. Anyway, thank you. Yes. She said you guys have a Samoa cookie. Hey, I did come over there. I was going to come in if you were there, but you weren't there. I kind of did a drive-by stalking. Yeah. I know I was, as a teacher, guys, I do that quite often at businesses. Like, do I know anyone in that one? Nope. Oh, on this one I do. 3 items. It works all the damn time. I am not kidding. I would never hire a high school student ever. Or just understand 3/4 of your product is gone. Except for you. You don't distribute product. Would you like to know some free math knowledge? Right? Oh, really? You can't show me how you teach it? Would you like to? That's cool. Yeah, I need help with math. Anyway. Yeah, I don't know. Do I? Do I do pretty good? You be honest. Is there days I struggle? Sure. Good. Okay, we're here. Now, ladies and gentlemen, look how close this is. This is pretty close. How did I do that? You guys missed the steps because you were chit-chatting about other things. I distributed cosine through. You see me now? No, I times by cosine top and bottom, which I can do that because that's timesing by what? 1. Yes, ma'am. What I wanted to do is I hate having a number over a fraction. That's why I did it. Does that make sense? It just so happened that we're gosh darn close, aren't we? This is the easy way. Say again, I'm sorry. Okay, so let's talk about what you would notice. What do you think you would have noticed? So you're a giver-upper. Okay, thanks, Templeton. Which you can't do that yet because you don't have a common denominator. So I could have done, Kelsey, a common denominator and then flipped it, and then that would be okay. But you would have to get that denominator to have a common denominator. So that means that I'd have to times him by cosine top and bottom, right? And then you'd do the same thing. It would be the same thing as basically what I'm doing here. Okay? Does that make sense? Okay, so ladies and gentlemen, what does, that's not the same. They don't like negative sign on top, do they? They had just regular sine cosine, didn't they? I wonder how I can make a negative into a positive. Times by what? And if I do it to the top, I got to do it to the bottom. So notice the top now becomes over, this is timesing by -1. Those are negatives. I don't know why I don't have a. What's cosine times -1? Negative cosine. What's negative sine times -1? Sine. By the way, you remember how I gave up this morning? Are you in first period? Remember how I gave up on this problem? I finished it my way. It was a little bit nastier, but I got it. Thank you. There it is. Isn't that what we were trying to get? Okay, I would like to keep this problem, but stop where I did something different, because I'd like to just to show you, keep persevering and we can get stuff done. Everybody know what I did? Once again, what did I tell you I did? Times by the conjugate. Oops. So as I distribute that negative sign through, I get negative sine x minus sine squared x over cosine x over 1 minus tangent squared. Because notice, guys, sine times negative sine times 1 is negative sine. Remember, tangent, sine over cosine, so hence sine times sine is sine squared over cosine, right? Is everybody there with me? Okay, what is a way? What is a way? Because this is not an identity. I kept putting this as secant squared, but it's not. What's another way? Same thing as we did earlier. What's another name for tangent squared? Sine over cosine squared. So we're here. Negative sine x minus sine squared x over cosine over 1 minus sine squared x cosine squared of x. Okay, what number can I times, or what can I times top and bottom to get rid of my denominators? Cosine squared, right? If I times cosine squared top and bottom, that's not very pretty. Okay, now watch what happens here. I got to distribute top and bottom. So the top will become this. Negative. What's up, Jay? Good. Minus sine squared cosine. Can anybody tell me why I only have one cosine, not a cosine squared? Because I have a cosine squared on top, but one cosine down below. So that allows me to get rid of one of those, right? Now how about on the bottom? What does it become? Cosine squared of x minus sine squared. Now it doesn't look like this way is easier, but I just, once again, I want to show you if we persevere, even if we make a bad choice, we still can probably get there. But is this as easy as the last one, do you feel? No, it's not. Okay? What does the top have in common? They have a negative sine squared. I mean, a negative sine of x and a cosine of x, which leaves me with cosine of x plus sine of x. And I think, David, you were about to talk about something on the bottom. What is it called? But that's plus, but that's not a plus, that's a minus. That's not -1. Difference of squares, good. I'll show you. I know you didn't really want to see this, but I'm showing you anyway. If I make him a -1, then I have to times this whole side by -1, right? So cosine would also have to be a negative with him. Does that make sense to you? So it has to be both and not just one because they're both the same sign. Answer your question? Okay. Good question, though, but does it make sense why we can't do that? But as Aaliyah just brought up, they are a difference of squares, right? And that difference of squares goes to cosine x minus sine x. What's the other side? Cosine x plus sine x. I wonder what that's nice about. What happens? Those guys are gone. And then we're back at that same situation of almost being there right here, huh? And that's where I times -1 top and bottom. I'm back at that same time, huh? Make sense? So then that would be sine, cosine over sine minus cosine. Okay? Two different ways, right? I want you to be aware it's fine, and that's why this test does take a little bit of time consuming for me. Did I talk to you guys about tests? When did I tell you the test was? Never? Well, at first, it was going to be the last day before spring break, which is on the 28th for us. But did a little calendaring, and that would have meant that we didn't have a review day. And I believe this test is one of the bigger tests of this quarter. It's my belief. I mean, your opinion might be different than my opinion, right? Hence why I said I believe. Touche on that, eh, Hoser? Anyway, I believe this is it. So here's what we're going to do. We're going to have a review day, the last day before the end of before spring break, which is March 28th. Is that Thursday back there? March 28th. Okay? We're going to have a review day. We get back. We're going to have a secondary review day. So I'm not going to make you test as soon as we get back. I'll give you another review day, and then we'll test on that Wednesday. You think that's a fair deal? The only con about it is that you are non-mathing for a week, right? So I might give you just a little review page, but some extra identity problems to kind of study, just so you can do it. I know not everybody's going to do it because it is spring break, whatever, but I just feel like having a review day is kind of important for this test. Do you guys agree that's okay to take the test in that fashion? We okay with that? Brother's like, I'm ready now. I haven't even learned it. Give it to me. Here. What is it? What does it say in Shrek? Hear the roar. Eat the roar. What is it? Do the roar. Do the roar. Do the roar. Anybody have one more? We've done quite a few of them. Doing even 38? Didn't we do 38 already? It's the same lesson as last time. What's the only difference? We know where we're going. Now, I haven't done a problem. Let me do a problem that is where we might have to work on both sides. Okay? Because right now I've only worked on the left side, correct? So let's go ahead and work on this side. 68? I don't think I even assigned that. I'll see if I can find one that works on both sides, but I can't ever tell until I do them. That's the problem. That one's simple. 19. You guys should love 19. It's an easy one. I'm proud of you. Love it like you live it. Huh? Have we did 16? Sixteen's a no? That's not a double-sider. This one says that we could work on both sides. We'll try it. Let's try it. This will be our last one. That's an equal sign. All right, what I see here, ladies and gentlemen, is on this side, I understand that to be, what's another name for cotangent squared? What is it? No. Nope. What? It is. That was an easy one. Oh, because it's not the same one that I wrote. Oh, shiz, I'm horrible. Let's erase. I was going to say, I was like, this problem's way too easy. I was really questioning. I'm like, what the heck? There we go. That's it. Okay, so we are going to start with what's another name for cotangent squared? Cosecant squared minus 1, right? Can anybody tell me what is cosecant squared minus 1? What is it called? It does not equal sine squared. What's another name for cosine? What's another name for cosine squared minus 1 besides cotangent squared? Difference of, what does difference of squares go into? Difference of squares, thank you. This is Belle over here. She's not paying attention at all. This is 16. And then she's like, conjugate pairs. Do you need a refill? You sure? Because I'm about to pound it. Pound it. No, I'm going to get some water in it. Then I'll have flavored water for tonight's range. That is from 4:30 to 8:30. I get to be here without seeing my family at all today. Because by the time I get home, they're supposed to be in bed. Well, you chose to be here. Because you're like, I haven't seen my family for like 6 months. I don't know. Huh? 'Tis the truth of your birthday. Go get the mini cup in the office. You'll see the mini cup. Nope, that is not the mini cup. Just get the mini cup, damn it. So I'm left here at cosecant theta minus 1. It's kind of hard to adjust him. Okay, I don't know where to go for him. So I'm going to come back up here. What's another way to write 1 minus sine theta over sine theta? Isn't that 1 over sine theta? Nope, come here. Did you not see the mini cup? Yes, you only get the mini cup. It's your birthday, and I love you that much. You're lucky this wasn't my important stuff. I did already sing. You don't ever pay attention to my voice. I did say Feliz Cumpleaños. That's basically singing in my mind. Is that the same way how you'd say it in Portuguese? How do you say it in Portuguese? What the hell? That was like super dupery fast. Do you guys agree that this is the same thing as the one right below it? Yes, sir. In my book it is. No, it's not 16 anymore. It's out of my textbook. That is 1. But do you guys agree that this goes to him? All I did is I put him under individual items, right? 1 over sine minus sine over sine, which is, what's this? What's this? Cosecant theta minus 1. Look at that, guys. I got them equal the same thing. Can you work on both sides if needed to get them to equal something? Yes. Okay? No, I don't know, brother. I don't think that hard. You think deep. I totally agree.